Hi guys, welcome back to my channel Communicate, and I am back with yet another video which is specifically useful for synthetic chemists who synthesize compounds on day-to-day basis and very often need spectral information of some known organic compounds, but they do not have access to it or might not have those compounds available in their lab to collect their data. And to resolve this issue, here is an easy solution. So this is a spectral database of organic compounds which is organized by National Institute of Advanced Industrial Science and Technology, Japan. So this database is not a predicted collection of data, but it is a collection of data which is experimentally reported. So let me show you how this works. So we'll just scroll down and press on this agree button. Okay, so this is how your screen looks like when you do that. So this is the main page where you will put in the information of the compound that you are looking for. So there are some options that you can in which you can put the information about your compound. It could be your compound name, it could be the molecular formula, molecular weight, or the Cas number. So let's just try some examples. So let's just try putting some simple organic molecule like 1,5-cyclooctadiene, which is already present here, and just press the search tab. Let's see what happens. So this is what we get when you do that. So the first output here is of 1,5-cyclooctadiene, and some other compounds or rather complexes are some example in which 1,5-cyclooctadiene is present, but we are specifically looking for 1,5-cyclooctadiene. So here is the molecular weight, and it tells us that Y means yes and N means no, of course. So it tells us that it is having the mass spectra, 13 carbon NMR spectra, proton NMR, IR and Raman, and not ESR. But that's obvious because ESR or EPR is not for 1,5-cyclooctadiene type of compounds. We know that EPR is a technique which is mainly for compounds having unpaired electrons. Never mind. So let's just check out how does the information that it tells us looks like. So let's just check its proton NMR first. So this also gives you the whole spectra as well as the peaks that are there, the shift in the proton NMR spectra. It tells you that in which solvent it is recorded. Here it is written that it is recorded in 0.5 ml of deuterated chloroform. Similarly, you can also click here and get the 13 carbon NMR spectra, which is also recorded in deuterated chloroform with the shifts reported for this compound. It also gives you the mass spectra of the compound. Well, this is how it looks like. So in this way, if you know the name of the compound, you can simply put the name of the compound and will get the information what you are looking for or what is available in this database. Now let's just go back and try to put some other information by which we can get this information. So instead of compound name, I might just put in the Cas number, right? So let me just put in the Cas number of some other organic molecule. For example, maybe this pyrrole here. So let me just copy paste the Cas number of this pyrrole from here and try putting it over here. Okay, so let's just see what happens when we do that and press the search tab. Oh, okay, well, it didn't work, but it should have, right? So let's see what went wrong. Well, we have put the Cas number here, but it still says that we have not given any input here. So the problem here is, I suppose, is that as you can see that there is still a space between the Cas number and in this search tab. So let's just remove this extra space here and try once more. Well, voila, it works this time. So this is a small thing that we must remember, that there should not be any space when you put any Cas number or write any name of the compound or molecular formula. This website reads it as that there is no input. So just a small trick for you guys in case you think that it does not really work. So anyways, here is the information of 2-pyrrole carbaldehyde, that the cas number of which we have put in the input section. So here is the molecular weight. It tells you again the mass, the 13 carbon NMR, proton NMR, and IR of this compound. So just like 1,5-cyclooctadiene, it will show you again the spectra of this compound. Here is the proton NMR. This is also reported in deuterated chloroform. It tells you that it is reported as 89.56 megahertz. Similarly, we can look for its 13 carbon NMR as well. So this is a quick way to get information that you're looking for, that can help you compare your own spectra with these known compounds and try to find out those extra peaks that you might see in your spectras and try to identify, okay, what are those peaks. So such database are really helpful. Now you can play around with this database, try to put in some other things. Maybe if you don't have the compound name, you can also try putting in the molecular formula, or you can also try to put in the molecular weight and have an estimate of, okay, this could be this compound or maybe this compound, depending on the proton NMR data that you get from this website. So I hope this tool is useful for you and you know help take advantage of this database in your own research. I'm sure that it will help you in case you are a synthetic chemist, especially because it's used very often for synthetic chemists. So in case it is useful for you, then please like, share, and subscribe to my channel. Do not forget sharing these videos, especially with your researcher friends. So I'll see you next time. Bye bye.